Welcome to day 2. We're going to figure out some exact values of trig functions. So we're going to go to some special right triangles, but we're going to be able to do sine, cosine, and tangent of all the special angles on the unit circle. We'll talk more about unit circles again tomorrow. But the whole idea of these special triangles, this is what you did from geometry class. The 30, 60, 90 right triangle and the 45, 45, 90 right triangle, and they have these little lengths here. So on a 30, 60, 90, the short side is 1, the hypotenuse is 2, and the long leg is radical 3. And on 45, 45, 90, the two legs are 1, and the hypotenuse is radical 2. So looking at these special right triangles, we're going to do the 30, 60, 90 one first. And we're going to do sine, cosine, and tangent of 30 degrees. And I already have my SOHCAHTOA rules by the side here. SOHCAHTOA being sine is opposite over hypotenuse. Well, 30 degrees, I have opposite over hypotenuse, or I have 1 over 2. At cosine, I have adjacent over hypotenuse, which is radical 3 over 2. And finally, for tangent, I have opposite over adjacent, or I get 1 over radical 3, and you can just leave a radical in the denominator. I'm going to let you know, of all these ones that I'm going to do, the only one I really know is this one. That's the only one I really know. The rest I kind of figure out. Okay, let's go to the 60 degree. Well, sine is still 60 is going to be opposite over hypotenuse. I get radical 3 over 2. Cosine is going to be adjacent over hypotenuse, so this is 1 over radical 2, and tangent is opposite over adjacent, which is radical 3 over 1. I'm just going to leave as radical 3. I do notice some trend here. The one trend I do notice is that this answer of sine of 30 degrees was exactly the same as cosine of 60 degrees, and cosine of 30 degrees was equal to sine of 60 degrees. And that has to do with the word cosine. Cosine is the complement of sine. Complement, CO, meaning two angles that add up to 90 degrees are what we call complements. 30 and 60 are complements. That's why the sine of 30 degrees is equal to the cosine of 60 degrees. If you take any two angles that are complements, let's talk about 20 degrees. I don't know what the sine of 20 degrees is, but I know that it's complement 70 degrees. That means cosine of 70 degrees would be exactly the same value as sine of 20 degrees. You should try that on your calculator. I'm going to go to the other triangle, and sine of 45 degrees is going to be opposite over hypotenuse, which is 1 over radical 2. Cosine, I'm going to get the same result, 1 over radical 2. That's because 45 degrees is its own complement. And tangent is opposite over adjacent, which is 1 over 1, which is just 1. Now you could leave it as 1 over radical 2, but I'm probably going to, just because for these I tend to write them this way, I don't mind the 1 over radical 3s, that won't bother me, but I like the radical 2 over 2. So I'm going to use these values from above to complete this whole table. Basically, these angles of 0, 30, 45, 60, 90 degrees is what makes up quadrant 1. These are our special angles that we're going to talk about. And the sine of 0, which we did yesterday, we saw was equal to 0. The sine of 30 degrees is equal to a half. The sine of 45 degrees is equal to radical 2 over 2. The sine of 60 degrees is equal to radical 3 over 2. And the sine of 90 degrees that we saw yesterday was equal to 1. And if you notice, I put these little numbers in here. I see a little 0, 1, 2, 3 pattern when I look at the here 0, 1, 2, 3 pattern for the numerators for the sine function. Again, I'm going to use these values Cosine of 0 degrees is equal to 1. We learned that yesterday. Cosine of 30 degrees is equal to radical 3 over 2. Cosine of 45 degrees is equal to radical 2 over 2. Cosine of 60 degrees is equal to 1/2. And then cosine of 90 degrees is equal to 0. If you notice that these values on the tables are basically reversed. The ones in blue go 0, 1/2, radical 2, radical 0, 2, 1, and this goes in reverse order because of this whole idea that cosine being the complement of sine. So I do notice a very good pattern that 1/2 and radical 3 over 2 are going to be by each other all the time, and radical 2 over 2. Even 0 and the 1s, they're going to be coupled together. And then finally I have to do tangent. Well, tangent is just y over x, or sine over cosine, but it's also the slope of something. We'll talk about that in a minute. But using these values here, tangent of 0 is equal to 0 over 1, or just 0. Sine over cosine here, so tangent of 30 degrees, so what we did before is 1 over radical 3. Tangent of 45 degrees is equal to 1. Tangent of 60 degrees is equal to radical 3. And tangent of 90 degrees. This is the weird one because it's going to be sine over cosine 1 over 0. This is undefined. Because what do we have here? We have 1 over 0. So if we want to look at slopes, we should know at 0 degrees, the slope of a 0 degree angle, well, that's 0 over 1. That's a horizontal line. And we know that slope is 0. At 45 degrees, if I do sine over cosine, it's radical 2 over 2 over radical 2 over 2. That just equals 1. The slope of a 45 degree angle line is just going to be 1. Undefined is a vertical line. That's kind of why we get a 1 over 0. We know the slope of a vertical line is undefined. Okay, and the other ones kind of work out. If it's 30 degrees, a slope of 30 degrees should be less than 45 degrees. That's why it's smaller than 1, and so on and so forth. So every angle that we're going to talk about can be referred back to a quadrant 1 reference angle, some angle between 0 and 90 degrees. That's why we call it an acute angle. So it is any angle in, well, I don't know why I wrote this. Any angle is a acute angle in quadrant 1. Okay. So we're going to look at these green angles is my angle I'm looking at compared to the red angles. So the green angle is the standard angle that I'm trying to figure out, and the red angle is its reference angle, what I call that little slice of pizza that is in an acute less than 90 degree angle. So when we're in quadrant 1, theta prime is equal to the original, same thing as theta, because they're both in quadrant 1. When I'm in quadrant 2, the reference angle, because I'm always trying to figure out reference angles, because if all I have to do is know quadrant 1, then I'm in good shape. That red angle, theta prime, is equal to 180 degrees minus theta. So when I'm in quadrant 1, it's 0 through 90. When I'm in quadrant 2, it's from 90 to 180. So if I have some angle in quadrant 2, let's say 120 degrees, its reference angle would be 180 minus 120, or 60 degrees would be its reference. When I'm in quadrant 3, those are angles from 180 to 270, and its reference, theta prime, would equal that big green angle, theta, minus a half a circle, 180 degrees. An angle in quadrant 3 would be something like 225 degrees, so 225 minus 180, its reference would be 45 degrees. And finally, quadrant 4 is any angle between 270 and 360, so theta prime would be a full circle 360 minus whatever theta is. An example for that would be 330 degrees. So 360 minus 330 would be 30 degrees. 30 degrees would be its reference angle. Because what we're going to talk about how I only need to know those numbers on that first page, which is quadrant 1, and I can figure out sine and cosine and tangent. And we'll talk about those other three, secant, cosecant, cotangent, those functions, the exact values, because that's what we want to know. So here, on this part of the paper, is exactly what it says up on top. But I figured out there's a little special pattern going on here. Okay, and for these special angles, and what I mean by the special angles, we're going to talk about those 135s, the 210s, and so on and so forth. Not any angle. You know, this will not apply to 55 degrees or 100 degrees or stuff like that. So I'm figuring out for these, and everything's going to refer back to one of these angles. These are all the angles that I did on the front page that came from quadrant 1, 0 through 90, the special angles. So if I have an angle on the x-axis, that's because it's divisible by 90 degrees, but there's two types of angles that are divisible by 90 degrees. So are angles on the y-axis. So if it's on the x-axis or y-axis, it's divisible by 90 degrees. You have to figure out which one it is. If it's on the x-axis, its reference is always going to be 0. If it's on the y-axis, the reference is always going to be 90 degrees. If it ends with a 5, pretty easy to tell if something ends with a 5. Again, 55 doesn't apply to this. It has to be something like 45, 225, stuff like that. Its reference will be 45 degrees. It's divisible by 60. Its reference will be 60 degrees. And if it's none of the other ones, the 1 through 4, the only thing left is 30 degrees as a reference. Let's talk about examples. 180 degrees is divisible by 90 and it's on the x-axis. It's on the negative x-axis, but it's still on the x-axis. Its reference would be 0. 270 degrees is divisible by 90, except it's on the y-axis. It's on the negative y-axis, so its reference is 90. 135 degrees is a special angle, ends with a 5, its reference is 45. 240 degrees is a special angle. It's in quadrant 3. It's divisible by 60, so therefore its reference is 60 degrees. And the last example is 330 degrees. 330 is not divisible by 90. It doesn't end with a 5. It's not divisible by 60. The only thing you could have is its reference angle is 30 degrees. So it says to complete quadrant 1 of the unit circle, and right here is quadrant 1 of the unit circle. So I'm going to complete all this information with all the x's and y's and angles and this and that. So I've completed the quadrant 1 picture with all the angles and all the x and y values, and I know that all the x and y values from these ordered pairs are all the cosine values and all the sine values, because I know cosine, sine, x, y, alphabetical order. And I also know that tangent of any of these angles is going to be sine over cosine, which is the y values over the x values, and I'm going to call that's the slope. So I'm going to put a letter m in all of these. Well, the m here, m of a flat line is 0. This m here in the middle is 1. This m is a little bit smaller than 1, so 1 over radical 3. This m here is bigger than 1, radical 3. I'm going to do this one in red. This m here for the 90 degrees is undefined. I'm putting in red because it is undefined. That will help me figure out this whole table, and I'm going to also use this, all students take calculus, for the other quadrants. So I'm going to use this information to complete this table. Specifically, I'm going to do quadrant 1, which we already did on the front page, but this shouldn't be too hard. So in quadrant 1, let me do quadrant 1. From 0 to 90 degrees, this is quadrant 1, and all things are positive. So I'm going to do sine, cosine, and tangent. Well, the only one I really know is sine of 30 degrees is a half. Married to it is radical 3 over 2 for cosine, and sine over cosine was 1 over radical 3. And that's the slope right there. At 45 degrees, I had radical 2 over 2 for the cosine. For the sine. Sine has cosine has to be exactly the same, and something over itself is 1. And at 60 degrees, I take the reverse of what I did for 30 degrees, so I get radical 3 over 2. I get 1/2, and now I get radical 3. Now at 90 degrees, a little bit trickier. I'm going to switch these. I get 1 for the sine, 0 for the cosine, and because this will be 1 over 0 instead of 0 over 1, tangent of 90 degrees is undefined. Now for these, the cosecant, the secant, and cotangent, these are their reciprocal functions of the first three. So all I have to do is take all those fractions and turn them upside down. So since this is secant and cosecant go together, cosine and secant, tangent and cotangent, hopefully you remember that. Taking 1/2 and flipping it upside down, this becomes a 2. Radical 3 over 2 flipped becomes 2 over radical 3. I'm okay with the radical. And 1 over radical 3 flipped is radical 3. I'm going to take these, I'm going to flip them. I would normally get 2 over radical 2, but that was really equal to a radical 2. That's the one I'm going to use. This is the same result, and 1 flipped upside down is 1. I'm going to take radical 3 over 2 and I get 2 over radical 3. 1/2 becomes 2, and this becomes 1 over radical 3. 1 upside down becomes 1. 0 is really 0 over 1, so this becomes 1 over 0, which is undefined. And 1 over 0 flips becomes 0 over 1, and that is just equal to 0. So I think we're learning that 0 and undefined are reciprocals of each other. And what's going to happen is that I'm going to use these 5 rows. I'm going to use for quadrant 2, quadrant 3, and quadrant 4 on the rest of this table. And that's how I generate this whole table. I don't really memorize the whole thing. I memorize a couple pieces, like sine of 30 degrees is a 1/2. And that anytime I have an answer of 1/2, the other one for either sine or cosine has to be radical 3 over 2. Tangent is sine over cosine, and the cosecant, the secant, and cotangent are just the reciprocals of those first three. That's all I really do. Okay, for quadrant 2, from 90 degrees to 180, I'm going to play the game of what's a reference angle. 120 is divisible by 60, it's 60. 135 ends with a 5, it's 45. 150 isn't divisible by 90 or 60, ends with a 5, this has to be 30. And 180 is divisible by 90, it is on the x-axis, so this is 0. So these numbers that I did in the top rows, I'm going to do exactly the same numbers here. So for 60 degrees, I had radical 3 over 2, 1/2, radical 3, 2 over radical 3, 2, and 1 over radical 3, except that this is quadrant 2, and only the sign is positive. So this is positive. If sine is positive, then cosecant is also positive. Therefore, cosine and tangent and secant and cotangent are negative. And I think you're going to see in the rest of the table that out of the 6 in the row, 4 out of the 6 have to be negative. So in the first 3, 2 out of the 3 will be negative, and the second 3, 2 out of 3 will be negative. I'll do the same thing for 45 degrees, radical 2 over 2, radical 2 over 2, 1, flips upside down is radical 2, flipped upside down is 1, just taking the reciprocal of the first 3, but sine is positive, cosine negative, tangent negative, cosecant positive, negative, negative. So I completed the next 2 rows for quadrant 2. Now I'm going to make sure I make the cosine and tangent negative and the secant and cotangent negative for both of those. I don't have to do it to zeros or undefined because you can't have a negative 0 and undefined is undefined. Okay, so in the green I did quadrant 3. I put all the numbers in. I didn't put any negative signs in yet because I want to show you that these numbers here in blue are the same numbers that I had for 30 degrees on the top. So in quadrant 3 only tangent is negative. Only tangent is positive, so it means sine and cosine are all negative. don't have to do for 0, and therefore cosecant and secant are all negative. And that's how I play this game, figuring out this whole chart. And I did the same thing for quadrant 4. I put in my reference angles, I filled in the rows corresponding to what I had in the top of the table. And in quadrant 4, cosine is positive, so sine are all negatives, and so is tangent are all negatives. I don't have to do for zeros, and therefore cosecant are negatives, don't have to do for undefined, and so is cotangent, leaving only the cosine and the secant values with positive. Okay, I hope you can understand how this table works. I don't memorize it. I know a couple things. I know sine of 30 degrees is a half. I know what things are coupled together. I know all students take calculus. How I know all 4 quadrants, which ones are positive, which ones are negative. I understand the pattern for my reference angles. So I do memorize a couple things, but I don't memorize the whole thing. Thank you.